In this video, we're going to study special linear equations. The linear equation has infinitely many solutions if the expression on the left-hand side is exactly equal to the expression on the right-hand side. Let's say we have 2x plus 3 on the left-hand side and 2x plus 3 on the right-hand side. This means for all values of x, 2x plus 3 is always equal to 2x plus 3, right? Let's say x is 1. Then the value on the left-hand side will be 5. The value on the right-hand side will be 5, right? They're equal to each other, right? So 1 can be the solution of this equation. Let's say if x is 2, then the value on the left-hand side will be 4 plus 3, 7. The value on the right-hand side will be 7, right? So the solution of x can be 2, right? Any value you plug in for x, this is always equal to this, right? So this equation has infinitely many solutions. All of the numbers are solutions. Okay? Okay, when we look at this equation, we must have same x terms on the left-hand side and right-hand side and same constant. Then this equation has infinitely many solutions. If we simplify this equation, we will have ax is equal to b form with a is equal to 0 and b is equal to 0. Okay, let's simplify the equation. So we're going to subtract 2x each side. So 2x minus 2x plus 3 is equal to, on the right hand side, 2x minus 2x, that's 0, right? So I'm just going to write 0 plus 3. So I'm going to subtract 3 each side, minus 3 minus 3. So we have 2x minus 2x is equal to 0 plus 0, 0, right? So using the distributable property, we can write 2x minus 2x as 2 minus 2 times x is equal to 0, right? And 2 minus 2 is 0. So 0 times x is equal to 0, right? So if we change this equation to this form, ax is equal to b, then that's going to be 0 times x is equal to 0, right? For any values of x here, then this is going to be always a 0 and this is always 0. So this equation has infinitely many solutions, right? Okay, concept check. We have a 4 plus 6x is equal to 2 times 3x plus 2. If we solve the parenthesis, that's going to be 4 plus 6x is equal to 2 times 3x, that's 6x, 2 times 2, that's plus 4. So when we look at the x terms, same, right? 6x is 6x. Constant, same, right? This expression is exactly equal to this expression, right? So we can conclude that this equation has infinitely many solutions, which means for all values of x, they're always equal to each other. Number 2, the linear equation has no solution if the expression on the left-hand side cannot be equal to the expression on the right-hand side. Let's say we have 2x plus 1 and we have 2x plus 2 here. Okay, for all values of x, this value and this value will never be equal to each other. Let's say if x is 1, this value is 3, right? This value is 4. 3 is not equal to 4. If x is 2, then 4 plus 1, that's 5. If x is 2 here, that's going to be 6, right? 5 is equal to 6. So this equation has no solution. For all values of x, the equation is always false. Okay? So when we look at this equation, the equation has no solution if they have a same x term but different constants. Okay? So when we simplify this equation, we will have ax is equal to b form with a is equal to 0 but b is not equal to 0. Okay, so let's simplify this equation. We have 2x plus 1 is equal to 2x plus 2. So I'm going to subtract 2x each side. So we have a 2x minus 2x plus 1 is equal to 2, right? So subtract 1 each side. So that's going to be 2x minus 2x, right? 2x minus 2x is equal to 1. And using the distributable property, I can write 2 minus 2 times x is equal to 1, right? 2 minus 2 is 0. So 0 times x is equal to 1, right? This means if we convert this equation to this form right here, a is equal to 0, but b is not equal to 0, which means for any values of x, right? 0 times x is always 0, but this is always equal to 1. So they are not equal to each other, right? Which means this equation has no solution. Okay, concept check right here. Let's look at this concept check. Here we have a 5x, same x terms, minus 4, plus 4, different constant, right? So we can conclude that this equation has no solution. Example number 2. The question is to solve the equation. So we have a parenthesis. Let's eliminate the parenthesis first. So we have a 6x minus 4 minus 9 minus 3 times 2x, 6x is equal to negative 13, right? So like terms, x terms, right? Constants. So 6x minus 6x minus 13 is equal to minus 13, right? So we're going to add 13 each side. So 6x minus 6x, using the distributable property, we can write that the 6 minus 6 times x is equal to 0. So 6 minus 6, that's 0 times x, right? So 0 times x is equal to 0. Well, this equation has infinitely many solutions, right? Because for all values of x, we plug in 0 times x. This is always a 0. This is always a 0. So this one has infinitely many solutions. Does that make sense? Or you can solve this way. Here, from this step right here, we have 6x minus 13 minus 6x is equal to minus 13, right? Here, 6x minus 6x, that's 0, right? So we can just write negative 13 is equal to negative 13. If the expression on the left hand side is exactly equal to the expression on the right hand side, what is that? The equation has infinitely many solutions, right? Number 2, let's eliminate the parentheses first. So 5 times 2x, that's 10x. 5 times minus 3, that's minus 15. Plus 2 is equal to 7x. Minus 3 times 2, minus 6. Minus 3 times minus x, that's plus 3x. So we have like terms. 10x minus 13 is equal to like terms. 7x plus 3x, that's 10x minus 6. Oh, we have same x terms, but different constant, right? Then this equation is always false for all values of x, right? So this equation has no solution. Okay, checkpoint 2. Solve the equation. For number 1, the first thing we got to do is we have to eliminate this denominator, right? So we'll have to multiply both sides of the equation by least common multiple. So let's find least common multiple. So we have 4 here, which is equal to 2 times 2. 8, that's 2 times 2 times 2. 4 here, that's 2 times 2. So least common multiple for these numbers is we must have at least 3 2's, right? So 2 times 2 times 2, which is equal to 8. So we're going to have to multiply all of this expression by 8, all of this expression by 8. So let's simplify this. 3 times 8, that's 24, minus 4 times 1 is 4. 4 times 2 is 8, right? So that's going to be 2 times 5 minus 3x. And this one is equal to, 8 times 7 over 8, that's just 7, plus, here, 4 times 1, 4 times 2. So 2 times 3x, that's going to be positive 6x. So we have 24 minus 2 times 5, 10, and minus 2 times minus 3x, that's plus 6x. It's equal to 7 plus 6x, right? So let's simplify this to, that's 14. So 14 plus 6x is equal to 7 plus 6x. When you look at this equation, we have same x term each side, right? 6x on the left-hand side, 6x on the right-hand side. But different constants, 14 on the left, 7 on the right. In this case, the equation has no solution because for all x, this is going to be false. This is not going to be equal to this, right? So no solution for this equation. But if you keep solving this equation right here, then that's going to be, we're going to subtract 6x here, subtract 6x here. So that's going to be 14. Let me write right here. 14 plus 6x minus 6x is equal to 7. Well, on the right hand side, I'm just going to write 7. 6x minus 6x is equal to 0, right? So now what I'm going to do is I'm going to subtract 14. Subtract 14. So 6x minus 6x is equal to minus 7. And 6x minus 6x is, that's 0, right? And 0, actually, I can write 6 minus 6 times x, right? Because x times 6, 6x. X times minus 6, minus 6x, right? So that is equal to negative 7. So 6 minus 6 is 0 times x, which is 0, right? So we have 0x is equal to negative 7. This means that the equation is always false for all x, right? For all x here, whatever number I substitute for x, this is always a 0. This is always negative 7. It's never equal to each other, right? So this equation has no solution. But at this stage of the solution right here, when we have same x term on the left, same x term on the right, but constants are different, then we can conclude that this equation has no solution. Okay, number 2, we have decimals in this equation. So what we have to do is we have to multiply by a power of 10, right? So we're going to multiply all of this expression by 10 and all of this expression by 10. Okay, so 10 times 1.8, that's going to be 18. And we have x minus 1 plus 10 times 0.5, that's 5, is equal to 10 times 3.6, that's 36. And we have 1 plus x over 2. And 10 times minus 4.9, that gives us minus 49, right? So let's simplify this. We're going to eliminate the parentheses. So 18 times x, that's 18x. 18 times negative 1, that's minus 18. And we have a plus 5 is equal to, 36 times 1, that's 36. And 36 times x over 2, 2 times 1 is 2. 2 times 18 is 36, right? So that's going to be 18 times x, which gives us 18x. And we have a minus 49. So let's simplify, left hand side and also the right hand side. We have two constants on the left hand side. So we have 18x minus 18 plus 5, that's 13, minus 13, right? It's equal to, here 36 minus 49, that's also minus 13. So 18x minus 13, right? At this point, you might notice that on the left hand side, right hand side, we have same expression, right? This means the equation is true, always true for all x. Any values of x we substitute here, this value is going to be equal to this value, right? So we can conclude that this equation has infinitely many solutions. This equation has infinitely many solutions. Okay? Or we can keep solving this equation. So let's remove 18x on the right hand side. So minus 18x. Then we also have to do the same thing here. Then this is going to be just a negative 13, right? Well, on the left hand side, it's negative 13, but I'm going to write 18x minus 18x. And we have negative 13. Now, we're going to add a 13 each side. 13 each side. And then this gives us, right hand side will be equal to 0. On the left hand side, we will have 18 minus 18x, right? But can I write 18 minus 18 and all of this thing times x, right? Because x times 18, 18x. x times minus 18, that's minus 18x, right? So finally, let me rewrite this expression right over here. 18 minus 18 is 0, right? So 0x is equal to 0. This means for all x, any x we substitute, this is going to be always a 0, and right hand side is always a 0, right? So this is always true for all x. So that means the equation has infinitely many solutions.